Hey guys, welcome back. This is Tim. So today we're going to hopefully fix the energy reader. In our previous video we soldered the parts on it and soldered the jumper wires on it and the diodes, and we discovered that it wasn't working. So I've got the schematic over here and I'm going to test each connection to make sure that there's a good and stable connection between all the components. So let's get started right away. Alright, so I will test with the ground connection to make sure that ground's available everywhere. So again, with the multimeter, and there should be a ground right over here, and there is a ground, and then the RX to this pin of the chip over here, that is working. Then the TX to, let me see, the middle pin of this chip, that is working as well. Alright, so and the ground of the VCC connection. Check that and after the diode it goes to this package and this pin, yeah, and to this one, yeah, and to this one. Ooh. No response there. So we've got one component that is kind of... Oh wait, maybe because it's of the diode. Yeah, I think it's because of the diode. I think I should put... Yeah, if I swap the leads, then it will work. Oh no, it doesn't. That's very strange. Alright, so now this middle connection to this connection, that is working, and I'm not sure if it's only working when I put pressure on it, so I'm going to very gently probe it. Yeah, that's working, that's connected. Alright, and now this one to this one, that is working. That's also connected to, yeah, to the 1K. Let's measure the resistance. Yeah, 13K, so that should do. Resistance of this baby is 180, that's fine. The resistance of this one is overload. No, 13K. And this one also 13. So the resistors are alright. Let me check where the... yeah, we've checked the RX. And this should be connected to ground. This one, no, through the, yes, there you go. Wait, yeah, and this, oh wait, that's ground. So everything is working, and that's very strange because there's no signal. So I've got an Arduino over here that sends out the text "Hello World" with a delay of 100 microseconds. So if we connect the ground and VCC pins to the Arduino, unplug it first, we should be able to see that voltage on the chips. So let's check that. So ground and VCC are 5 volts. So that is connected. Now let's connect the USB. So alright, so the reader is connected. Can't feel anything getting hot or something. So that should be no problem. So let's switch to voltage measuring and let's check. So this pin and this one should measure 4.2 volts. That's a little low for 5 volt rail, if you may call it that way. So over here we've got a voltage of, ooh, yeah, 5 volts. And over here we've got a voltage of less than 5 volts, but that is expected. Well, I wasn't expecting 0 volts, but well, let's check if all the capacitors are connected then. So that should be this one. There is a capacitor option on my multimeter. So let's measure this. 2.95 microfarads. That is a little high, but the others could be causing that. 5. Well, I think we'll just need to touch up the solar pads. Right, let's see a few pads that are not really connected. So I've already heated up my soldering iron. And hope that this works. Yeah, that did work. Let me turn on my fan. So, oh, my tip came loose, sort of. So that should be connected right now. That should be connected. There's a little too much solder on the resistor over here. There's a little too much solder on this one as well. So let's remove that. solder wick is getting hot, of course. So that's okay. Now this one. This one. And yeah, that was the one I was doubting about. Oh, if there was a good stable connection. So let's put some solder on it then. A little solder, not too much. So that should do. Give it a bit of a push inside. So that is connected. There's a giant blob of solder right there that we need to remove. So that should be removed. And it is. Touch a bit there, touch a bit. Oh, there. This one is barely connected. Yeah, the bad connections are the fault of my solder paste experiment. It didn't go that well, as we can see afterwards. But hey, you gotta learn something, right? And somehow. This one is not looking very pretty. So touch that one up a bit. That's good. Alright, so that should work right now. If this doesn't work, then I think we've got another issue, of which I don't know the origin. So let's connect it and let's check the voltage. Those two over there. So that's one. Now I've only connected the 5V and the ground lines, so that no data will be transferred to on my multimeter, and plug in the Arduino like that. So still nothing on the output. I don't know if this camera is able to see infrared light. I hope we will find out very soon, but hey, for now let's check the voltages. So here we are. I've only attached the receiving side of the reader, and I need to properly configure my oscilloscope, so that is good. The threshold's a little low, but that shouldn't matter very much. Now I will need to set up the G-code and the idle level, which is high, so no data will be passed when the idle level is high, because the level is always at high when there's no data incoming. If you can see, that's part of the protocol that the energy meter is using. So yeah, so let's get back, and the signal, if we already had that, this should this is a custom baud of 300. I've set it up in the Arduino software. So 300 and okay. Alright, and I haven't connected the sending there yet, but I will do that right now. So that should be this one, and connect it to a ground. So there's no data on that line. Maybe if we try the other pin of the LED. Oh, there you go. We've got something. Bring this one down a bit and scale this one down. Bring this one down. And oh yeah. Oh, no history. Just change the display setting. No, that's over here. Binary. Add to ASCII. And we should represent it. Well, at least there's something. There's an O. Why there's a 7 over there, I don't know. Is there any possibility that we could have flipped the diodes in the process of soldering? Well, only that one, not this one. Because the data is going over the now. There shouldn't be. There shouldn't be any possibilities. Maybe I've just smoked out the diode. We could, yeah, that could be the case. So let's get my lab bench on and test the diode. Let's turn it on. Now let's operate a voltage of 3 volts. So let's set that around 3 volts. And well, let's increase the voltage when we've connected it. The output is off. And I already can see the first problem. The alligator clips don't fit over the leads of the LED. They're too big. So no. I think we need to batch in some jumper wires then. I don't know. Or we might be able to bend it and place the well, I think I'll just connect it to the ground over here then. Or no, I will remove the plastic cover of this one. Let me get my tweezer where I have it made on here. If that's enough. There you go. So that's removed. So now we can safely attach the clip. Now let me turn off most of the lights so we can see the infrared signal. Let me get my phone, because I know for sure that my phone is able to see the signal. And that's, yeah, nothing's happening. Alright, that's good. There you go. There is the... This is not an infrared light, this is just a blue LED. And we should be able to connect it to... Let me double check that. To the right one. And now the left one. To there. No, that won't clip on. So in the end, I got a little jumper wire So that should be able to connect to there. And now we should be able to see the light if the thing works. If the LED is still working. And if the LED is not working, we know that's our problem. So one more time, this one. Now I know that nothing's happening because I've turned down everything. Let's raise it to around 1.5 volts. I've got a little hook attached to it, and I'm going to turn on the LED supposedly, and hopefully see something light up. Now there's not much current being drawn for the LED. In fact, zero current is being drawn. So I think we did something wrong. Alright, so let's use some solder wick in order to remove the right diode. That's rather important, I think. Wait. And let's get some solder out. I think the flux is missing. Like that. And try it again. Like that. So that should work. Alright, so I hope that the rest of the components, let me change to a smaller tip. Because this is the largest tip I've on here. And that will remove other components for sure. There you go. So now good tip. Turn it back on. And the thing falls down. No problem. Remove this side. There you go. Yes. Alright, so now I've removed it, fortunately, and now whilst it's loose, I'm going to test it. So turn the thing back down. Yeah. That's a short circuit. So. Ow, that's hot. This is not good, baby. I'm at 3.8 volts and really nothing's happening. Again, no current flow. I'm at 4.8 volts, no current flow. So that means that we've got a bad IR light. So let me get another one, and I'll be back with you very soon. Now, just to make sure that everything else is working, here's a red LED attached to the lab bench, and at 2.6 volts it's pulling 6 milliampere. So I think I will temporarily attach this diode to the circuit and see what it does. Get the solder wick, check if it works this time. No. Solder sucker for the win. If the pad heats up enough, which it does right now, and let's push the pin let's turn it on. It's drawing current, and it's working. We've got a working IR LED. We've got the working IR diode. So now, where's my circuit board again? Here. Oh, it's still attached. Let's remove it. Remove that one. The inside was the negative, so we need to orient it like that way. Let's get my pliers. So yeah, there you go. Now we need this one as well to go in a little further. And by a little I actually mean quite a lot, but it isn't going. I think this is a quite good time to use the air blower again. And hope I don't burn my fingers, because that thing's hot. I am burning my fingers. So wait for the solder to melt. There you go. There you go. Oh, I'm not sure if it's a little too far. No, it isn't. Damn, this LED's huge. But that's a winner, actually. So let's solder it on properly. You can't wait. Let me turn off the light first. And there you go. Is this the correct? Wait, let me grab my phone and... Oh, no. Yeah, there you go. There you go. So I think that's a winner. So now we should be able to communicate with the energy meter. I will continue this project in another video, because we've fixed the hardware. Everything's working. The soft and the hardware is working, and we've just lost 2 connections. If I put something reflective over it, yeah, look. Look. When I'm pointing the IR LEDs into the mat, which is IR reflecting, the RX pin lights up. Let me zoom into that for you. So no reflecting Etimet, reflecting, no reflecting, no reflecting, reflecting, no reflecting. And as you can see, the IR pulses are almost the same. I think there's a little time offset, but I think that this is working correctly. Right about time. Alright, so I will continue this project in another video. So please stay tuned. That video will cover the creation of the case, because this will go into a case. I've also purchased some magnets, some neodymium ring magnets that will well, hopefully fit around the case, and it's already attracting here. That hopefully will fit around the case. Well, hopefully that will fit in and around the case, because I'm going to design the case myself. And these magnets will stick to the energy meter, because the energy meter has got a magnet interface. And yeah, it will hold it in place. Oh shit. So I need to be careful not to break them, but if I don't break them, I should be able to gently place them up. Yeah, there you go. So, neodymium ring magnets working on our blaster LED and receiver. So, I will see you next time. Thanks for watching. If you like this video, please consider sharing it. And if you want more of this content, you are very welcome to subscribe to my channel. If you think your friends are going to like this channel, make sure to share it with them, so they can check this channel out too and have some great ideas and inspiration for some project. So I hope to see you again very soon.